What's up, guys? In this episode, I'll go over the binomial expansion questions in exercise 1N. So, question 1, we can jump right into it. So, observe the following pattern with the coefficients. We have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. And with the x terms, we have starting with full power, x to the power 4, x to the power 3, x squared, x to the power 1, x to the power 0. And for 5, it goes the other way around. Starts from 0, 1, 2, 3, and 4. And we're going to join all the terms by pluses. Okay, this is basically the general way to actually do any binomial expansion. But you will see that some of them are going to be ones and, well, a lot of ones there. So, for example, this number, the first one is always 1. The last binomial coefficient is also 1, always 1 instead as well. And then we have like this, let's call it like the b term. If there's like a plus b to the power of 4. This b term is also 1 always. And this last a term is always going to be 1 always. And then we also have some of these here that, we don't have to write down these exponents there. So I could just simplify, like right in the beginning, I can write the order like this. X to the power 4 plus 4 choose 1, x to the power 3 times 5. 4 choose 2, x squared 5 squared plus 4 choose 3, x 5 cubed plus 5 to the power 4. And then you also see that these indices always add up to 4. Okay, there is a hidden 1 there, hidden 1 here. Okay, these indices for each of these terms here will always add up to 4. So that's also another nice pattern. And the last step is to actually simplify everything. 4 choose 1. A nice property about some of these coefficients is n choose 1 is always going to be n, and then n choose n minus 1 will always be n as well. For example, 9 choose 1 will be 9, 9 choose 8 will be 9 as well too. So very helpful when we want to do the last and the second and the second last binomial coefficient. So this will always be the same. And then we have x cubed times 5 plus a choose 2. So I'm going to write it down here. A choose 2 can be written as 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. So they cancel out. And then all you have left is 12 over 2, which is 6. So that's there. Now another way to actually do 4 choose 2 is to think of these as, well, using falling factorials. Basically, 4 choose 2 means that you want to, on the top, you want to do 4 times 3 times blah, blah, blah until there are 2 numbers here. So this number on the top tells me how many of these you want to multiply on the top. And on the bottom, it always starts with this number here until the end. So you can think of the bottom always going to be 2 factorial. The top here, sometimes it's called 4 taken to 2 terms over 2 factorial. So this will be this here. Very helpful when you want to do this by hand, especially if the number is small. So for example, if I have 7 choose 3, I can do this as 7 times 6 times 5 over 3 times 2 times 1 on the bottom, which is 3 factorial, right? And then notice that 3 times 2 times 1 is exactly 6. So just cancel that, and that gives us 35. So this is just an aside. So going back to that question up here, we have 6x squared times 25. And then we have 4x times 125 plus 625. And then we can still simplify this. This will be 20, 150, 500, 625. That's the final answer. Okay, it seems like a lot of work at the beginning, but now I'm going to do it much more efficiently. So the next question here, I'm going to go straight into doing 2 to the power 5 plus, I'll still write down 5 choose 1, even though I know it's 5. Okay, so the middle coefficients, I will usually write them out. And then this will be 2 to the power 4 negative b to the power of 1, which is negative b, plus 5 choose 2, 2 cube, negative b all squared, 5 choose 3, 2 square, negative b all cubed, 5 choose 4, 2 times negative b to the power 4, plus negative b to the power 5. And what I usually do is, I will actually, in my head, I will do this in my head. So this will be a 5. And I'll actually expand out all the coefficients as well too. So 2 to the power of 4 is 16. And then here I'll do that over here. 5 choose 2 is going to be 5 times 4 over 2 times 1, which is 10. And then we have 8 here. So that's 10 times 8. 5 choose 3, I know this is the metric. So I know this and this will be the same. So therefore this is also 10. 10 times 4 for that matter. Here we have 5 times 2. And I'm going to simplify everything now. 2 to the power of 5 is 32. So therefore this 32 plus this 80. And then negative b, right? So with the negative b, instead of writing plus negative b, why don't I just do minus 80b? Plus 10 times 8, again, we have 80. This time, the b here is negative b all squared, so it stays positive. So if I collect the coefficients, this will just be 80b squared. And I know this is going to be minus because of the pattern that I see. So this is going to be alternating, since this part here now, with cubed, it's going to give us a negative. The coefficients is 10 and 4. This gives us 40. So it'll be 40b cubed. Then it will be plus 10b to the power 4 minus b to the power 5. So it gets faster and faster as you are getting more familiar with how to collect the coefficients. Next one. So I do 2 to the power 2x to the power of 6 plus 6 choose 1, 2x to the power of 5 times negative 1 plus 6 choose 2, 2x to the power of 4, negative 1 all squared, 6 choose 3, 2x all cubed, negative 1 all cubed, 6 choose 4, 2x squared, negative 1 all to the power of 4, 6 choose 5, 2x, negative 1 to the power of 5, and negative 1 to the power of 6. So just like before, we can write down the coefficients. This is technically 2 to the power of 6 when you expand out the indices. So 2 to the power of 6 is 32. 6 choose 1 is 6. 2 to the power of 5 is 16. 6 choose 2 is 15. So 15 times 2 to the power of 4 will be, why is that 16 again? 2 to the power of 4 is 16. That means I got this wrong. Whoops, my bad. This 64, this 32, this 16. I'll worry about the minus 1 later, because it's just a difference of plus or minus in this example. If that was not minus 1, if it's minus 2, I would have taken care here as well too. Maybe I should do it here. Yeah, why not? Let's just do it here. This times negative 1. This one is times 1. So 6 choose 3 is 3 to 1 is the same as 6. So that's 20. 2 cube is 8. Negative 1 all cube is minus 1. 6 choose 4 is the same as 6 choose 2. So therefore this is 15 by symmetry. So I took that and mapped it over here. 2 square is 4. -1 all to the power of 4 is still +1. 6 choose 5 is just 6. It's 2. -1 to the power of 5 is an odd number, so it's -1. And the last one is +1, or just 1. So we take these numbers and write those out in the front before the x terms. So this will be 64 x to the power of 6. 6 times 32, oh, that's a minus. 6 times 32 is 192. So 192 x to the power of 5. 15 times 16 is 240, so this plus 240. 20 times 8 is 160 with a minus. X cubed. 15 times 4 is 60 with a plus. 6 times 2 times -1 is -12. And the last one is a 1. Okay, seems like a lot of work, but it's just a lot of calculation. Alright, this is 4x to the power of 4 plus 4 choose 1. 4x all cubed y plus 4 choose 2. 4x all square y square. 4 choose 3. 4x all times y cubed plus y to the power of 4. Coefficients, we have 4 choose 1 is 4. 4 to the power of 3 is 64. And then 4 choose 2 is, what is it, 6. 4 squared is 16. 4 choose 3 is 4. That's 4. And last one doesn't even have a number. So if we simplify, oh, I should have done the first one. 4 to the power of 4 is 16 times 16, 256. So this will be 256 x to the power of 4 plus, that's also 256, x cubed y. 6 times 16 is 96, x squared y squared. 4 times 4 is 16, x y cubed, and y to the power of 4. Oops. Oh, this one's a cube. I like cube because it's small. So we start off with x cubed plus 3 choose 1, x squared -3y, plus 3 choose 2, x times -3y all squared, plus -3y all cubed. So here 3 choose 1 is 3, and then we have a -3. 3 choose 2 is also 3. -3 all squared is a +9. And the last one is -3 all cubed, which is -27. So if we collect the coefficients, this is a -9, sorry. 3 times -3 is -9, and then x squared and a y. 3 times 9 is 27, and then this will be xy squared. And the last one will be -27y cubed. X all to the power of 5 plus 5 choose 1. Not thinking. 3x to the power of 4 times 4y plus 5 choose 2. 3x to the power of 3 times 4y squared plus 5 choose 3. 3x all square, 4y all cube plus 5 choose 4. 3x times 4y all to the power of 4, and the last one is just 4y all to the power of 5. Ooh, this one seems a bit more intense, huh? 3 to the power of 5 is 9, 27, 81, 243. 5 choose 1 is 4. Looks like a 6. 3 to the power of 4 is 81. And then times another 4. 5 choose 2 is 10. 3 to the power of 3 is 27. 4 squared is 16. 5 choose 3 is the same as 5 choose 2, so it's again 10. 3 squared is 9. 4 to the power of 3 is 64. 5 choose 4 is 5. times 3, go away. 4 to the power of 4 is 16 times 16, 256. And then times another 4 is, I think, 1024. And you really need to have a calculator for this. Please use a calculator. So combining the coefficients, we have 243 x to the power of 5 plus 5 times 81. Let's do 5 times 4 is 20. 20 times 81 is 1620. And then let's do 16 times 27, which is 162, 432, 4320. And then 9 times 64 is 576, so 5760. And then here, oh my goodness, let's do 256 times 5, which is 1280 times a 3 is 43840. And then 1024. And here you are. Hope you learned something, and I'll see you in my next video.